Hey everyone, welcome back to KnowledgeHeals, your go-to place for making maths clear, simple, and fun. Today, we're going to deep dive into exercise 3 from the chapter Trigonometric Functions, one of the most important and concept-rich parts of Class 11 maths. From basic identities to principal and general solutions, and even solving complex trigonometric equations, this exercise covers it all. We'll learn how to apply trigonometric identities like a pro, solve tricky equations using general solutions, understand sign conventions using quadrants. Whether you're preparing for your school exams or aiming for JEE, mastering this exercise will give you a solid grip on trigonometry. So don't skip any part because each question brings a new twist and a new trick to learn. Let's start exercise 3, trigonometric functions. Right here, right now, only on KnowledgeHeals. We will see your first question, that is 2 cos pi by 13 into cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13, which is equal to 0. Let's focus on our solution, that is LHS equal to RHS. Here we will use the identity of 2 cos A into cos B in equation, and we get cos of pi by 13 plus 9 pi by 13 plus cos of pi by 13 minus 9 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. As we simplify more, we get equation cos 10 pi by 13 plus cos of 8 pi by 13 plus cos 3 pi by 13 plus cos of 5 pi by 13. Now we will make use of identity cos of minus theta is equal to cos theta. Now we can again rewrite this equation, and we have to make sure denominator remains same so that you can prove it easily. Cos of 13 pi minus 3 pi by 13 plus cos of 13 pi minus 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. As the equation is in second quadrant, the equation becomes cos of pi minus 3 pi by 13 plus cos of pi minus 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13, which is equal to minus cos of 3 pi by 13 minus cos 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13, which is equal to 0, that is RHS. Hence, it is proved. Now let's check our another question, that is sin 3x plus sin x into sin x plus cos 3 x minus cos x into cos x, which is equal to 0. Let's see our solution. Here we will focus on sum and difference formula. So our equation becomes 2 sin 3x plus x by 2 into cos of 3x minus x by 2 minus 2 into sin of 3x plus x by 2 into sin of 3x minus x by 2 into cos x, which is equal to 2 into sin 2x into cos x into sin x minus 2 into sin 2x into sin x into cos x, which is equal to 0, that is RHS. Hence, our equation is proved. Let's see our third question, cos x plus cos y the whole square plus sin x minus sin I. The whole square equal to 4 into cos square x plus y by 2. Let's prove our equation and move forward to our solution. LHS is equal to 2 into cos x plus y by 2 into cos of x minus y by 2, the whole square plus 2 into cos x plus y by 2 into sin of x minus y by 2 the whole square. As we move more, we take out 4 cos square x plus y by 2. As we simplify more, as you can see, we get equation 4 into cos square x plus y by 2 into 1, which is equal to 4 into cos square x plus y by 2. Let's move on to our fourth question, that is a cos x minus cos y the whole square plus sin x minus sin y. The whole square is equal to 4 sin square x minus y by 2. That equation we have to prove. Let's focus on our solution, and here we will use CD formulae, which is equal to minus 2 sin of x plus y by 2 into sin of x minus y by 2, the whole square plus 2 into cos of x plus y by 2 into sin x minus y by 2. The whole square. As we simplify more, then we can take out 4 sin square x minus y by 2 common, and we get equation 4 sin square x minus y by 2 into sin square x plus y by 2 plus cos square x plus y by 2. Now we will use identity. Sin square theta plus cos square theta is equal to 1. So we get our required equation as 4 sin square x minus y by 2, which is equal to RHS. Let's see our question 5. That is another proof. We need to prove that sin x plus sin 3x plus sin 5x plus sin 7x is equal to 4 into cos x into cos 2x into sin 4x is equal to 4 into cos x into cos 2x into sin 4x. Let's focus on our solution, that is sin x plus sin 3x plus sin 5x plus sin 7x, which is equal to sin 7x plus sin x plus sin 5x plus sin 3x. As you can see, we have used some formula in equation, and we get 2 into sin of 7x plus x by 2 into cos of 7x minus x by 2 plus 2 into sin of 5x plus 3x by 2 into cos of 5x minus 3x by 2. Now we will take 2 sin 4x common, and we get 2 sin 4x into cos 3x plus cos x. Now we will use sum to product again, and we get 2 sin 4x into 2 cos of 3x plus x by 2 into cos of 3x minus x by 2, which is equal to 4 into sin 4x into cos 2x into cos x, which is equal to RHS. Hence, our equation is proved. Let's see our next proof, that is sin 7x plus sin 5x plus sin 9x plus sin 3x divided by cos 7x plus cos 5x plus cos 9x plus cos 3x, which is equal to tan 6x. Let's move on to our solution, and we will use some formulas, and we get an equation that you can see on screen. As we simplify it more, we get 2 sin 6x into cos x plus 2 sin 6x into cos 3x divided by 2 cos 6x into cos x plus 2 into cos 6x into cos 3x. Taking 2 sin 6x common from both numerator and denominator, we get sin 6x by cos 6x, which we further solve, then we get tan 6x, which is equal to RHS. Hence, our equation is proved. Let's see our question 7 proof, and our question is sin 3x plus sin 2x minus sin x, which is equal to 4 into sin x into cos of x by 2 into cos of 3x by 2. We have to prove this equation. Our LHS is sin 3x plus sin 2x minus sin x, which is equal to sin 3x minus sin x plus sin 2x. Then we will use identity, sin a minus sin b in equation, which is equal to 2 into squares of 3x plus x by 2 into sin of 3x minus x by 2 plus sin 2x, which is equal to 2 into cos 2x into sin x plus sin 2x. Now we will use sin 2x equal to 2 sin cos x, which is equal to 2 sinx into cos 2x plus cos x. Then we use identity of cos A plus cos B, and we get equation 2 sin x into 2 cos of 2x plus x by 2 into cos of 2x minus x by 2, which is equal to 2 sin x into 2 cos of 3x by 2 into cos of x by 2, which is equal to 4 sin x into cos x by 2 into cos 3x by 2, which is equal to RHS. Hence, our equation is proved. Let's move on to our 8th question, and from now we need to find value of sin x by 2, cos x by 2, and tan x by 2. Our question is tanx equal to minus 4 by 3, where x is in quadrant 2. We know quadrant 2 is pi by 2 is less than x is less than pi. We will divide the whole equation of quadrant 2 by 2, so we get pi by 4 less than x by 2 is less than pi by 2. Hence, x by 2 lies in first quadrant, so all trigonometric values of x by 2 are positive. As we know, cc square x equal to 1 plus tan square x, so we substitute value of tan x, and we get sec x equal to plus minus 5 by 3. But important thing is, x is in quadrant 2, so sex is negative, so our equation becomes sec x equal to minus 5 by 3, and then qs x becomes minus 3 by 5. Now we will find value of sin x by 2 by substituting value in equation sin square x by 2 is equal to 1 minus cos x by 2. As we substitute the value and simplify it, we get sin x by 2 equal to plus minus 2 by root 5. But as x by 2 lies in first quadrant, then sin x by 2 is equal to 2 by root 5. We also know another identity because square x by 2 is equal to 1 plus cos x by 2. We already have value of cos x, and we substitute in equation, we get cos x by 2 is equal to plus minus 1 by root 5. But x by 2 lies in first quadrant, then we get cos x by 2 is equal to 1 by root 5. as we have the values of sin x by 2 and cos x by 2. Then we get tan x by 2, so we get the value of tan x by 2 is equal to 2. Hence, we have got our values of sin x by 2, cos x by 2, and tan x by 2. Let's see our other equation, that is cos x equal to minus 1 by 3, where x lies in third quadrant. As we know, third quadrant is pi is less than x is less than 3 pi by 2. Now we will divide whole quadrant equation by 2. That is pi by 2 less than x by 2 is less than 3 pi by 4. Now we know value of x by 2 lies in second quadrant, so that sin x by 2 is greater than 0. Cos x by 2 is less than 0, and tan x by 2 is less than 0. We will substitute value of cos x in equation sin square x by 2, and we get equation sin square x by 2 is equal to 1 minus cos x by 2. Therefore, when we equate, we get the value of sin of x by 2, that is plus minus root of 2 by 3. As sin x by 2 is greater than 0, so we get the value sin x by 2 is equal to root of 2 by 3. We have value of cos x, then I can substitute in equation cos square x by 2 is equal to 1 plus cos x by 2. Therefore, cos x by 2 is equal to plus minus root of 1 by 3. But as we know, cos x by 2 is less than 0, so cos x by 2 is minus 1 by root 3. Now we have values of sin x by 2 and cos x by 2, so we will substitute values in equation tan x by 2. After substituting values, we get minus root 2. Hence, we have find values of sin x by 2, cos x by 2, and tan x by 2. Let's see our last question, that is sin x equal to 1 by 4, where x is in quadrant 2. As we know, quadrant 2 is pi by 2 is less than x is less than pi. Now we will divide quadrant 2 equation by 2, and we get pi by 4 less than x by 2 less than pi by 2. X by 2 lies in first quadrant, and so all trigonometric ratios of x by 2 are positive. Now we will substitute value of sin x in equation of cos square x. Then we get answer cos x equal to plus minus root 15 by 4. As x is in second quadrant, cos x becomes minus root 15 by 4. Now we will substitute value of cos x in equation sin square x by 2. And as further we simplify the equation, so we get the value of sin x by 2 as root 5 plus root 3 by 4. Now we will find value of cos x by 2 by substituting values of cos x in equation. We get cos x by 2 is equal to root 5 minus root 3 by 4. Now we will substitute value of sin x by 2 and cos x by 2 in equation tan x by 2 we get. Value of tan x by 2 is 4 plus root 15. Hence, we get the values of sin x by 2, cos x by 2, and tan x by 2. And that brings us to the end of Exercise 3 Trigonometric Functions from Class 11 NCERT Maths. We covered everything, from identities to equations, and even how to find values in different quadrants. I hope all your concepts are now crystal clear. If you still have any doubt, don't hesitate. Drop it in the comments and I'll be there to help you out. Don't forget, practice is the key. Try to solve these questions again on your own without looking, and you'll be surprised how much you've learned. If this video helped you, make sure to like, share, and subscribe to KnowledgeHeals, because here we make maths not just understandable, but also enjoyable. See you in the next chapter. Until then, keep learning, keep growing. KnowledgeHeals. Let me know if you'd like a Hinglish version too.